Good evening, all of you. Today I will discuss with you, we call it as an analysis of algorithm. Basically, in a program, the backend, how the algorithm works, what is the time complexity of that algorithm, each and every evaluation, how much time it takes, not in the machine. We cannot say how much time it will take in the machine. As far the algorithm is concerned, how much number of iteration, or we can say that the how much time slots it takes. Suppose if we say an loop statement for I is equal to 0, I is less than 10, I plus plus. Then it will take first 0 and it will go to 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means including 0 and 9, there are 10 flops. And we calculate this as the time complexity of that. Now suppose if we say, suppose I will give you a small example. If I say there are two loops for I is equal to 0, I is less than 5 and I plus plus. Within that there is another for j is equal to 0, j is less than 5 and j plus plus. So in an iterative program, how much time it will take? That means there are flops. So suppose if when I is equal to 0, j will rotate how much time? 0, 1, 2, 3, 4, 5. Similarly, when I is equal to 1, j will rotate 0, 1, 2, 3, 4, 5. So if I add, when I is equal to 4, j will rotate 0, 1, 2, 3, 4, 5. So for the 0 of I, j will rotate 1 to 0 to 4. Now I cumulate. For I is equal to 1, when I, this is I, right? This is I, right? So I is equal to 1, that time j 0 to again 4. So similarly, when I is equal to less than 4, j is equal to 0 to 4. Now if I add all, here it is 5 loops, here it is 5 loops, here it is 5 loops. So 5, 5, 5, 5, 5, total 5, 5, 5, 5, 5. That means 25. Now, what is the maximum value we have taken? 5. So that is why we can say, if I take 5 as per the outer loop, I will get, here it is also 5. So total number of flops, not in the machine, total number of flops is equal to 25. That is 5 to the power 2. That's why we call order of n square. Now, if I say n is equal to 5, this one, this n is equal to 5, where it is n. So n is equal to 5, I will get 25. That is why we call order of n square. This is one aspect in the iterative. Now, how to calculate the recurrence relation? The algorithm called by itself. That is the beauty of this algorithm. Before starting to this analysis of algorithm in a recursive mode, I will tell you something. First, I will rub all these things, right? Now, I will tell you what is recursive algorithm. We all know that recursive means that procedure or the function called by itself. That is the basic idea of that. Now, suppose I will give you an example. Suppose x, y, z. This is a function. Suppose this is a function. Now, this is a function. This is a curly braces. I'm sorry. This is a function. This is a curly braces. Now, suppose I have wrote something, and I have called x, y, z. This is a function. That means what? This is called in the memory. Memory never recognizes this is as a function. This is inflate in the RAM within the same space. Now, interesting part is that suppose this xyz inflate in the memory. So this first line will execute first, then the second line will execute first, then when it will call this one, the same set of program will call by itself in the memory. Now what happens actually? If I write xyz, suppose this is the box. This is the first xyz. X, Y, Z. Now when it calls first line, second line, first line, second line, third line, it is again wrote X, Y, Z. That means what it will happen? After that there is another statement, suppose. So this X, Y, Z opens from this curly braces to this curly braces whole. Now this another block will open in the memory. This is the interesting part. Now, this same line will again open up. Now there is x, y, z with the bracket, and one statement is here. Here is also one statement. Now the beauteous part is that this x, y, z again open up another. Now how we call this time complexity? Now, suppose I have put a condition over here. Here I have put a one condition. If something do, then this xyz will not run. So in that case, this xyz will not run because of the if statement. Now what happens? We call, so the control will move on from this line to this line. So this line will execute. And this whole part in the RAM will burn out. We call it as a burnout. That means these are not in the memory segment. So this, if I write here, suppose I have wrote return. So the control will go where? That is the interesting part. The control will go where? Every calling function, suppose this is xyz, this is a function. Here I have wrote pqr. This is another function. This function calls PQR. So this is a calling function, this is a called function. This is actually a mother function and this is actually a child function. What do we mean? Now, interesting part is that when this XYZ returns, from here it is returns. So this set of instruction opens when this executed. That means this is the mother function of this whole code, and this is burnout. So return will automatically goes to here, and then the work of this function has been finished, done. Now this return, the control will move on to this return. So this return will send the control to its mother function, and then this will again execute, and the return will goes to the parent or the main function. Now here, how I calculate the time complexity, how I know the time complexity of this algorithm. Now I will give you a small example. Now I move on to the another slide and I will tell you the explanation. Suppose I want to write a program to find out the factorial, how it works, the internal how executes, each and every step. I will basic things I will explain. Then we move on to the recursive, another procedure. What is the pseudocode of this one? Function factorial n we are going to pass. Suppose this is n is equal to suppose 5. Suppose if n is equal to 1, then factorial 1 it will return, else factorial is equal to n into factorial n minus 1. Now what happens? Whatever I have told you just before that, same, this is one function, these are the statements, and n factorial, factorial n factorial. So that means here we are going to return something, am I right? End of the factorial, this will return. Now what happens here, if I write this is a factorial, I will give you an example of that thing. Just now this is the factorial n. So first I will create first block. Very interesting. Now if n is equal to 1, suppose this is 5. So n is not that done here, this won't execute. Then what happens? This is factorial. This is factorial with the function. So here it is 5. Now these 1 and 2, line number 1 and line number 2 won't execute, not execute. Line number 3 else part, then the factorial. Now I have to write factorial is equal to n into factorial n minus 1. So this is another function and this is end of the factorial. End. That means return of the factorial. End of the factorial. This is a variable. Now this factorial is equal to n into factorial n minus 1. Now what happens? This is the function. This is the function. And for this one, it will open up a new set of lines in the memory. Here it is what? Here it is 5. Now this n is 5, this is factorial n minus 1. So that means it is 4. So if the new set opens 1, 2, 3, forget 4. So this will be again factorial is equal to n into factorial n minus 1. N minus 1. So this n is what? Because here it is 4. So this n is equal to 4 and this is 3. Now this is n into factorial n. So another will open up similarly, same. So here it is 3 and here it is factorial 2. Similarly, another will open is equal to f 2 into factorial 2 minus 1. That means it will be 1. It will again call. Now here 1. Now if n is equal to 1, now it has got 1. If n is equal to 1, factorial is equal to 1 and it will return. So that means here it is a factorial is equal to 1. So if it is 1, so this function, who is the mother? This factorial n minus 1 is the mother. So here f value, how much value? 1, n into no value 1, 2. So here it is 1. So this 1 will return to its mother function, this factorial. Now this has borne out. Similarly, this 1 into 2, so factorial is equal to 2, complete. Because this is borne out, so this function will borne out. So this 2 into 1, f is factorial is equal to 2. So here it is returned to whom? To its mother. It will go to here. If this is 2, so 3 into 2, factorial is equal to 6. That means factorial is equal to 6. And it will return. To whom it will return? It will return to here. And this is 6. 3 into 2, 6. Now 6 and this is borne out. This is already borne out. So 6 into 4, that is called 24. 24 will return to whom? 24 will return to its mother function here. And this 24 into 5, 120. End of the factorial. That means the return factorial. It will return to main. How much? 5 into 24. That means 120 is the answer. Now, our motto to find out, this is the internal, right? Now, our motto is to find out the time complexity of this kind of algorithm. Whoever is recursive in nature. This is very simple. If we go for the basics, then it is very simple. Now, first I will rub, then I will explain one by one. Now, we move on to the another slide. Whatever we have explained, here is the code. Already I have told you, n is equal to 1, then n, here n is equal to 5. If it is 5, then it is 5. This is 5 minus 1, that means it is 4. Again, by this set of instruction opened, so n is not equal to 4, not equal to 1. So here it will be 4 because this is 4. Already 4 called, so this is parent function, this is child function. If this is 4, so this will be 4 and it is 3, 4 minus 1, 3. This calls and this opens up. So if this is 3, so this will be 3 and this factorial 3 minus 1, that means here it is 2. So if it is 2, so this will be 2. And if this is 2, this is not equal to, so this will be 2 and this is the factorial 2 minus 1, that means it is 1. Now here, if it is 1, then it will catch this instruction, n is equal to 1, then factorial is equal to 1 and then return. So here if it is return, it will straightly go to its mother function with the value 1. So 2 into 1, end of the factorial, factorial is equal to 2 into 1, this factorial is equal to 2. Now if it is ends, so where it will go? It will go to its mother function 2. Here in full line it is 2. 2. 3 into 2, this is 6. The factorial is equal to 6. The end of the factorial, it will go to its mother function. But then it will be 6 ulta, returning. It never calculates in the forward direction. Always it will calculate to the reverse direction. So 6 into 4, now it is 24. So this factorial is equal to 24. Now end of the factorial, then it will go to its mother function. So here it is 24. Now 24 into 5, how much? This is 120. Then this factorial will go to its mother function. Suppose this is the main block. So this way, this actually works. And our target is to find out the time complexity. Now we move on to the time complexity part as well. Now this is the basic understanding of the recursive algorithm, recursive program. Now actually recursive program can be dealt by 3 types to find out the time complexity. First, the decision tree. Second, the back substitution method. These are the alternates, right? You can calculate the time complexity of any recurrence kind of algorithm. You can calculate by decision tree. You can calculate the time complexity by back substitution algorithm. And the third, the most important, you can calculate the time complexity using the Master's theorem. But Master's theorem has certain criteria that has to be met. Then only you can calculate the time complexity using the Master's theorem. So first we will go to that part of it. This is the architecture of any kind of recurrence solution. Already I have seen this is 5, then this 5 minus 1, recursive algorithm sort of. So whenever we will get this kind of, this function will be in its body. This is called the recursive function. Now, if I start to explain, void recursive time, this is n, suppose 5. Now I am going to print 5, then 4 minus 1, 4 minus 1 all itself, that means again it is 4, then print 4, 5, 4, then it will be 3, it will print 3. So first and foremost, what is the time complexity of this? What we call total time, not the time complexity. How? So how we calculate? First, this time, actually here when it runs, it will give me the total time. So how we write? We write the structure is Tn, total time. This represents the total time. Tn is equal to, now from that, if it is 5, next time it will be 4, next time it will be 3, next time it will be 2, whatever. Tn is equal to T of, now this depends on this kind of any values. Here you can write n minus 1, here you can write n, here you can write n by 4, here you can write n by 2, depends on the algorithm. Because suppose you have 10 data and you want to find out the time complexity of quick sort or mod sort, where we have to partition the data. So first time you have 10, we have partitioned, I am working on this 5 part and I am working on this 5 part. That means n by 2 first time. Next time another half, that means n by 4, n by 8, n by 16, n by 32. This is the approach. So in that case, might be this will be n by 2. This way we have to proceed. But the structure is this. This is a constant value. Either it will be n or 1. It depends on the algorithm. Now, first, now according to this algorithm, if we go, this is Tn, total time. If n is equal to 0, that means here only one check is there, whether n is greater or not, only one. So I have write 1. Printf, only single statement. Print, this is also 1. Now this is same algorithm, recursive time count n minus 1. If it is n, so this will be certainly Tn minus 1. Now we have to add up to this. How much you are getting? We are getting T of n minus 1 plus 2 or any constant value. That is why we have wrote Tn minus 1 plus 1. Now, if it is all 0 or less than 0, then what will happen? We will get a only constant value. That is why we have wrote only 1. Either how we write, then we will write, this is the style, Tn is equal to, make a curly braces, T n minus 1 plus, we have got a constant value, and it will be 1, when, if we make 0, so this whole will be 0, so only this value will be existed, so 0, when n is less than or equal to 1, or we can say less than, and here n is greater than 1 or equal to 1. From 1, if I have only 1, then 1 1 0, T0 is equal to 1, T0 is equal to 1, T0 is equal to 1. So that if I take 1, only 2 loops will be there. So this is the basic concept, right? That means at the end, we can say that, this is the style that we have to adopt. This is the style that we have to adapt to find out any time complexity zone. Here, what we already said, Tn minus 1, only Tn, or Tn by 2, or Tn by 4, any. We can write also log, we can use that one, right? Now, I have already told you, there are 3 ways that we can calculate the time complexity. One is for the recurrence relation. One is decision tree, another is back substitution, and another is master's theorem. We are going to explain the first part, and the rest part I will tell you in my next class, right? Now, what you have said, methods to find the time complexity in a recurrence relation. In the recurrence relation, when we have a function that calling and called functions, these are the 3 methods that we can adopt to find out the time complexity. All are very interesting. The first one is the decision tree, the second is the back substitution method, and the third one is the master's theorem. We go one by one. Now suppose I have only one algorithm. First I have to take one algorithm, then we move on, right? Now, what I have wrote, recurrence is the function what I have wrote, recurrence is the function, suppose this is n. Now, if n is equal to 0, within that, what I have wrote, for I is equal to 0, I is less than n, that means this is 5, I plus plus printf n, recurrence n minus 1, that means it is 4. This is a very beautiful example, and we have to find out the time complexity. We really don't know how to find out the time complexity. Now, move on, one by one. First time this is, suppose this is 5. So, if this is 5, 5 is greater than 5, now it is 5, this loop will rotate, 0, 1, 2, 3, 4, 5, now it is 4. It will call this set again, so this will be again 4, this will generate 0 to 4. So, it is very difficult when the complexity is much more or the programming coding is very much more. To find out this kind of time complexity, we have some mathematical models. Now, how we calculate? Now, if I take this example, first we need to find out that total time formula, Tn is equal to. So if I take Tn is equal to, then we will fit into any kind of mathematical model, either decision tree or back substitution method or master's theorem. Now, what is this Tn? Now I have wrote Tn. This is only a single statement. I have write 1. For I is equal to 0, I is less than n, I plus plus. That means what? 0 to less than n. You can write n or you can write n plus 1. Why? This is very interesting question. Some of the author or some of the mathematician, they said it might be n, and some of the mathematician or some of the author says n plus 1 you can write. When? That is the beauty. But both will give you the same result. Suppose you have one for statement, I is equal to 0, I is less than 10 and I plus plus. Now this is the curly braces. What will be the value here? Chalo, I am telling you. 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. 8, check. Okay, 8. 9, check. Okay. 10, no. So what we are writing? You are taking 0 to 9 as a value. So what you are saying? 0 to 9 means including 0, 1 to 9, that means 9 value plus 0, 10 number of rotations. So you are writing 10. So some of the author says, if it is 10, so this is n. You have taken 10. And some of the author says, suppose this is 9. It checks, yes, comes here. 0 first, then 1, then 2, then 3, then 4, then 5, 6, 7, 8, 9, okay. 10, no, outside the loop. That is why some of the authors, some of the mathematicians says, one execution is there, but there is no criteria matching, so it came out, but one execution is there. So, total number of values 0 and then 10 also, that means it is 11. You are taking 10 values. So that some of the author says this is n plus 1 and some of the author says this is n. No hassles, you can take n, you can take n plus 1. This is the beauty of it. Now suppose now what you have to do? There is, now suppose if I write here I is less than n by 2, then we have to write something different, and that is the beauty. This is n plus 1. If it is n plus 1, then this is certainly number of times n, because what we have taken, this is I plus 1 we have considered, 10 times it is considered. So for the consideration, this is 1 less than, so this will be 10. You understand? This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So 0 to 10 you have taken. So 0 and 10. Number of rotation 11. So 10, this won't execute here. This come out outside. So if it is 10, this will be 9 times. That is why you have wrote this. And this is recurrence n minus 1. Already you understand. If it is Tn, then this will be Tn minus 1. N minus 1. This will reduce 1 by 1, 1 by 1. So that we have to write n minus 1. Now you have to add full. This you have to add. What is the value? Can you tell me? First you write down this Tn is equal to this whole value. This whole value. Now I am going to write Tn is equal to Tn minus 1 plus n plus 1 plus 1. Now tell me. No, another n is there. Another n is there. Plus n. N plus 1. So what will happen? If you add up, you will get how much value? 2n plus 2. Now take the common outside. N plus 1. Then this will be 2n plus 2, that means 2 outside, n plus 1, constant term cancel out, then it will be n plus 1, then again n plus 1, constant term. So what we can write? N. So this is the ultimate formula. Each and every recursive algorithm have this kind of values. We call it as a total time. This is not the time complexity time, because you have to calculate in order of value, either big O or theta or omega, in that form. So to convert this into or big O, that means worst case analysis, we have 3 algorithms, 3 methodology. I have already told you, one is the decision tree, another is the what we call back substitution, and another is the master's theorem. So this is the formula, right? Now we move on. Now we will move on. I am going to give you an example of decision tree method. How it works. Decision tree means what do we have value? Tn is equal to Tn plus, sorry, Tn minus, I'm sorry, Tn minus 1 plus n. Right? Now, if I make this one, how it works? This is the total time that we have got Tn, and this is the Tn minus 1 plus n. So, if I take it this way, okay, this is Tn whole n. Now, this I have make it 2 parts. This is n, and this is Tn minus 1. Now suppose this n is equal to 5. This n is equal to 5. Then how much time it will take? This is 5, this is 4. Now this is n, that means it is 4, and this is t of n minus 1. You write down, this is 5, so this is 5. This is 4. This is 4, and this is 4. This is 3. Very interesting. Now this side is 3. This side is t of n minus 1. So this side is 2. Now this side is 2. Then this side is t of n minus 1. This side is 1. If this side is 1, this side is what? T of n minus 1. That means it is completely 0. So I can write 0. Now, first of all, you calculate the total number of slots. If I take this is n, make it n. This is what? These are the constant terms. This is what? N minus 1. This is n minus 1. This is n minus 2. Again, you have got n, 5. First time it is 5. That is why I have got n. This is n minus 1, 4. That means I am writing n minus 1. This is 3. Third state. All by itself. This is 3. So I am taking it as a 3. N minus 1. N minus 2. 3, no? N minus 2. This is n minus 3. N minus 3. This is n minus 4. N minus 4. Okay. And this is n minus 5. That means it comes out 0. Now what happens actually? So this is 2, 0, 1. Now this is n minus 4. That means here it is actually. Okay. This is 1. This is 0. So now if I take this as a value, so last one I got 0, then I got only 1, then I got only 2, and then dot plus what you are getting? N minus, here you can, what you can write? N minus decreasing order, n minus 2, then n minus 3 plus n minus 3, then n minus 2, no, 2, 1, sorry. If it is plus 2, so that means 0, 1, 2, this is 3 plus n minus 1 and so on. Now, I think you all knows this what is actually. What is this? This is total Tn equal to n into n plus 1 divided by 2. That means we go off, you are ready? If you calculate n square plus n divided by 2. So n square by 2 and another is n by 2. So forget about n by 2, n square by 2, that means highest value is n square. So that what we can say, this is n square. So this is we get using the decision tree method. Any value using this kind of decision tree, you can find out the total time. From the total time, you can calculate the time complexity as well. Another two methods, one is back substitution method and another is Master's theorem. In my next lecture, I will explain in detail with each and every minutes and the details. Thank you all.